Okay, today we are talking about rainwater harvesting systems. So what is a rainwater harvesting system? Basically, you are harvesting or collecting the rainwater that comes off of your roof on your home or business and collecting it in a large water storage tank that is opaque, not transparent or translucent because sunlight can proliferate the growth of algae inside your water tank. So what can harvested rainwater be used for? It can be filtered and sanitized and used for potable use in both residential and commercial applications. It can be used for landscape irrigation. It can be used in commercial and industrial spaces for water cooling tower makeup water, mop bucket refilling, scrubber cart refilling, car wash, closed loop wash racks, parts cleaners. The other major components of a rainwater harvesting system are as follows. You have a first flush device that is connected to your downspout from your rain gutters. I do not recommend just using a large diameter PVC pipe like you see in this graphic. Instead, I recommend like a small, maybe 100-gallon tank. Gives you more capacity. It can sit firmly on the ground. You don't have to bolt it to the side of your building. Easier to clean. As the name implies, the first flush device flushes out all the dirt, leaves, dead bugs, and bird poop that has accumulated on your roof during the dry season and collects that debris, that dirty water, inside the first flush device. It usually has a drain valve on the bottom of it that you will need to open at the end of a rain event to drain out that water. And then once that first flush device fills up with dirty water, there is a ball float or a flapper valve, one-way check valve that closes and causes the rainwater to then flow into your rainwater storage tank. Usually it's best practice to have a calming inlet that you see here and utilize a floating pump inlet with a mesh screen. That way you're not sucking water directly off the bottom of the rainwater tank or directly off the top. You're sucking it out of sort of the middle body of water in that opaque water storage tank. And I would recommend installing a UV sterilizer, a submersible UV sterilizer inside the water tank so it can run 24/7 and kill any germs or bacteria in the water for your sterilization or sanitization process. Any excess rainwater that you produce will flow out the overflow pipe. I would recommend installing a screen or a drain emitter pop-up valve. That will keep out bugs and other insects, rodents, from crawling inside your overflow pipe and getting into your water tank. You then want to have a pump that will pump the rainwater through a filtration system. The type of filter, the size of filter, the number of filters is up to your specific application. I'd recommend for an average homeowner 4-inch by 20-inch. You want like a sediment filter followed by a granular activated carbon filter. You don't need a water softening system with rainwater necessarily because rainwater is usually soft water. You'll also note this tank itself has a drain valve on it there. So if you need to perform maintenance and drain the tank out, you can do so. If we zoom in, you can see there's an air admittance valve on top of the tank here. And we seal around the lid where the rainwater enters the tank, again to keep out bugs and dust from getting in your tank. As far as the tanks go, they range in size and price. Again, go with an opaque tank. There's different suppliers out there. Just do a Google search. You can buy one big tank or several smaller tanks and daisy chain them together. As far as a pump, to pump the water through the filters and into your home plumbing or your facilities plumbing system, you can do a shallow well jet pump or just a jet pump, booster pump, etc., depending on your application. These ones here are nice because they're controlled by a pressure switch. So it'll turn the pump on when the pressure drops to a certain PSI and then turn the pump off when the pressure reaches a certain PSI. And there's usually a pressure gauge on the pump as well. And that bladder tank is usually half filled with air and then half filled obviously with the water. And here's a close-up detailed view of a floating pump inlet. They come in different sizes. You can see the screen and the float, so the inlet stays below the water line. And here is a calming inlet. You can buy one already. It slows the flow of water down and changes its directionality, so you're not dumping it directly into the tank. It causes it to kind of do a U-turn towards the bottom of the tank. Also helps add some oxygen to the water at the bottom of the tank. And if you don't want to buy one or can't find one, you can build your own out of simply two 90-degree elbows like you see here. And it's a good best practice to have a freshwater makeup valve. They make mechanical float valves like you see here on the left, or you can have a 120-volt float switch that when it floats down, it'll open a solenoid valve and top off the tank a little bit with water. That's what I would recommend. Something to note, depending on your local authority having jurisdiction, they may require an air gap fitting or a one-way check valve or a double check valve on your fresh water line that is supplying your rainwater tank for supplemental water, just simply because they don't want a chance having your rainwater be sucked back into the city's water supply. So again, it'll be different with every municipality. You can see here there's a air gap fitting on this tank. You can see the solenoid valve as well. And then the J box is attached to the float switch and the UV sterilizer down in this tank. And it's plugged into a 120-volt GFCI outlet. And the pump itself is also plugged into that 120-volt GFCI outlet. So it's a good idea to have a dedicated GFCI outlet or a GFCI protected circuit to power your pump, your float switch for the solenoid valve, and your UV sterilizer. And you can see in this graphic, we capped off the water supply line at the water meter and then installed a T up and over to supply our freshwater makeup valve. In the event for some reason we didn't harvest enough rainwater, it'll top off your tank just a little bit. You don't need to have it fill it up completely, but maybe a quarter of the way or a third of the way full, just simply so you don't run out of water until the next rain event. And to clarify, in your first flush device, if you're using a tank like in my demonstration here, the one-way check valve, if you will, you can buy them in different diameters. This one is a 4-inch diameter check valve. So as the water level rises inside your first flush tank, it's going to push up that float and close off the valve. I hope that makes sense. And you simply tighten the 4 screws on the top of this little one-way check valve, and it squeezes that rubber donut against the inside wall of your 4-inch pipe, and that's how you install it. They're actually designed mainly for like floor drains to keep sewage from backing up out your floor drain, but it works perfectly well for this application in a first flush device as well. Quick note on water quality: you can buy these water test kits to test the water from your rainwater harvesting system, or send out a water sample to an independent laboratory. You will have to pay for that, of course, and it takes several days to get results. As far as how much rainwater you can harvest off of your roof and how much you need, that's going to vary from person to person or facility to facility. What are you going to use the rainwater for? Non-potable use or potable use? How many people live in your building? How many showers do you take a day? How long of a shower do you take? What's the gallon per minute rating of your shower head, faucets, etc.? And the basic rule of thumb for calculating how much rainwater your roof produces, as you can see here, an inch of rainfall on a square foot of surface area yields 0.623 gallons. So multiply 0.623 gallons by the number of surface square feet of your roof. So an example would be 0.623 times 2,000 square foot roof equals 1,246 gallons of water. So for each inch of rainfall, your roof could collect 1,246 gallons of water. So over an entire rainy season, you can calculate how many inches on average does your area get of rain, and you can kind of figure out how much rain your roof can produce for you. I hope this information helps you. Have you tried using a rainwater harvesting system? How does it work for you? Let me know in the comments below. Please like, share, subscribe, leave me a comment, and thanks for watching.